Hello, Math 7 students. This is a continuation of our 6th grade review of Unit 3, Lesson 6, Interpreting Rates. Yesterday, in our last video, we did talk about the situation cooking oatmeal. We had these two different ratios, which at first we thought they were different because of the order that they were presented, but on closer inspection, we did realize that they're the same ratio, just flip-flopped or reversed. And then we also practiced finding out a unit rate, a rate per one. So what we're going to be doing now is we're going to be taking all of that information, our original ratios, and we're going to be answering these questions here. The next weekend after the camping trip, Lynn and Diego each decide to cook a large batch of oatmeal to have breakfast ready for the entire week. Lynn decides to cook 5 cups of oats. How much water should she boil? So to get started with this, I'm going to color code just so I can make sure that I'm using the information correctly. And before I was using orange for the oats, so 5 cups of oats. And the question is how many cups of water? And so I've color coded that water to be blue just like it was before. And I don't know the answer. That is the one that I am trying to find. So when I get started on this problem, I'm actually going to use the original ratios, okay? And we do have 2 options here. It doesn't matter which one we choose because they're the same ratio, just flip-flopped, right? So it's okay to use either one of those. I'm going to go ahead and just use this one just because it's the one that's closest. So when I scroll down, I can still see it. No other reason. I'm just choosing to use that one. And it says 15 water and 6 oats. That's the original ratio. And I want to get started here just to help give us an idea and explain that relationship that these things are always going to be connected to the original problem. And what we're really trying to do is we're asking this question now. 6 cups of oats has now been changed to 5 cups of oats. And we want to know how much water. So look at how I set up that ratio. Original information, new information, and I don't have all of the information. This right here is what I'm trying to find. So to get us started, I'm going to ask the question, how does a 6 change to a 1? Does anyone know off the top of their head how a 6 changes to a 1? Kaden M. Well, 6 divided by 6 doesn't change to 5 though. 6 divided by 6 changes to a 1. Why is it helpful to change it to a 1 though? Because I like that idea, but why is it helpful to change it to a 1? Because I can times it by 5. So let's go back to this question that I asked then. How does a 6 change to a 5? Does anybody know off the top of their head? Birdie. Okay, so if I took a 6 and divided it by 5, test that out guys in your calculator. 6 divided by 5. Is that going to change it to a 5? It doesn't, does it? So we are struggling with having to use mental math. How does a 6 change to a 5? We don't know. And since we don't know, we're going to go back to Kaden M's strategy and say, well, why don't we change it to a 1 first? Because, fun fact, we already did change it to a 1. We did that up here, right? Where I changed the 6 into a 1. How? What did I do to change that 6 into a 1? As Kaden said, we divided it by 6. So we will divide the numerator or that top number by 6, and 15 divided by 6. Again, we already did all of that. We did that in our last video. That's 2.5. Why is this helpful? As Kaden said, I don't know how to turn a 6 into a 5, but I know how to turn a 5 into a 1. And isn't it really easy once I have a 1 to change a 1 into any other thing? How does a 1 change to a 5 then? Good. Addie. We multiply it by 5. 1 times 5 is 5. So what should I be doing up here? The same exact thing, right? So 2.5 times 5, let's plug that into our calculators, and what do we get? 2.5, 2.5 times 5, and we get what, Emily? 12.5. Not just 12.5, but 12.5 cups of water, right? Okay, beautiful. So how much water should Lynn boil? She should boil 12.5 cups of water. Let's make that answer This is very abstract. Let's make it quantitative, math practice 2. So we will say 12.5 cups of water. Now, for this next problem, we're going to do the same type of thing, okay? The same type of strategy. We're going to set it up with the original ratio. And just so that this ratio up here doesn't feel lonely, I'm going to use it this time. We use this one here, right? And now I'm going to use this one right here down for this problem. So I'm going to set it up in the beginning with that original set of information. So again, I've got my 6 oats. I've got my 15 cups of water. And now it says Diego boils 10 cups of water. How many cups of oats should he add into the water? So again, what I'm doing is I'm trying to change this 15 cups of water into 10 cups of water. We don't know how many oats, so that's the information that I'm trying to find. It belongs up here. I don't know it yet. I'm going to ask this question. How does a 15 change to a 10? Do you know how to make a 15 change to a 10 very easily? What's your thought, Luke? We could subtract 5, but is it ever okay to subtract during these problems? No. So although we know how, when we ask the question thinking of multiplication and division relationships, is it as easy? What could we do then? Look at what we did in the last problem and talk with your group. Form a strategy. How can I make this easier? Since I don't know how to change a 15 to a 10, what should I do? Visit with your groups, please. Do you have some ideas? A few ideas. Good. All right. Timothy, what's your idea? Oh, I like that idea. I like that a lot. What Timothy said is he said, let's take the 15 and divide it by 3. We could take 15 and divide it by 3. What will that give us? That gives us 5, right? And can we change a 5 to a 10? Yeah. Timothy, I actually really like that strategy. I was thinking of something different, but I like that strategy so much. We're going to use it, and then we're still going to do it my way after. But I do like that idea. We don't know how to change a 15 to a 10, but we can change a 15 into a 5. So let's do that. The 15 changes to a 5 by dividing by 3. And the 6 would also then need to be divided by 3. And 6 divided by 3 is equal to 2 cups of oats. And now, can we change a 5 into a 10 very easily? Very easily. We are going to multiply by 2. So we need to do the same thing with the numerator. 2 times 2 is equal to 4 cups of oats. I love that strategy. That is a great strategy. And so we'll answer that quantitatively as well, because again, this is abstract. So we're going to answer and say 4 cups of oats. All right. Thank you so much for sharing that strategy. I want to show you a different way. And even though I'm out of space here for 2b, but I'm going to go ahead and use some of the space here for question 3 just to reset up that problem, because I want to show you another way. One that in a way is a little bit less work. So 6 oats, 15 water, that's the original one. And again, we've already decided that we can't very easily change a 15 to a 10, so I know I'm going to have to take that middle step. I'm just going to change what that middle step is. And that middle step, again, is one that we've already taken. If you look at A, we didn't know how to change the 6 to a 5, but I can always change a 6. I can change any number into a 1, right? And then when it's 1, I can change that number into any other number. And we already changed it to a 1 up above. Remember how we did that? And so since we already did that work, I just want to reuse that work that we already did. So that 15 cups of water, we can change it because we've already done it. We can change it into 1 water. because we can change any number into a 1. How did I change the 15 into a 1? By dividing by itself, right? 15 divided by 15 is 1. So what did I do here with the 6 up above earlier yesterday in the last video when I did the problem? We also divide by 15. And 6 divided by 15, 0.4. Yep, we already did that, so it's up here. I'm just going to scroll up to remind you all the work we've already done. So 0.4 cups of oats. And now we've taken a middle step. Different middle step than Timothy took, but we still took a middle step. And now we can ask that question. Can we change a 1 into a 10? Yeah, how does the 1 change to a 10? Multiplying by 10. And so the 0.4 is also going to be multiplied by 10. And 0.4 multiplied by 10. Plug it into your calculators. I'll wait. What's 0.4 multiplied by 10? Good. Lots of hands coming up. 0.4 multiplied by 10. What'd you get, Cheyenne? 4 or just 4, right? 4 cups of oats. Same problem, same answer that we got before. We just took a different route. Okay, I do like this route, finding a different number that's going to work, but one number that will always work is changing it to a 1. Because we can always change a number to a 1. We can always change a 1 into any other thing. Okay, so that's what's so beautiful. Now, I'm going to just move that answer a little bit out of the way. So that, and I know you guys can't do that. That's okay. Don't worry. Let's now talk about question 3. When we answered each of these questions, did we use Priya's rate, which was 0.4 cups of oats per cup of water? Or did we use Hans' rate, which was 2.5 cups of water per cup? Which ratio did we use? Just think about that for a second. Ask your group members what they think. Turn this to a group discussion. We'll come back together in about 30 seconds. Which ratio did we use to answer those questions? All right, which ratio did we use to answer those questions? Good. What are your thoughts, Brighton? Yeah, again, we used both ratios, didn't we? We used one ratio to answer question A, and we used the other ratio to answer question B. And I did choose those ratios on purpose. I did set them up that way. But I wanted you to see the value in any time I can change one of those numbers to a 1, like this 2.5 cups of water for 1 cup of oats. It means that we can change that 1 into any other number. So I used one answer, or one ratio here, when we knew the amount of oats. And I used a different ratio, it's actually moved down here, I used a different ratio here that had 1 for the water, so that I could then change the water to any number. So yes, we did use both ratios, a different one for each problem. Let's add that to our notes. Specifically, if I use the ratio with the 1, that's going to be the most helpful. That's what's called a unit rate, and we're going to be practicing those unit rates in the next couple of problems. Okay, are you ready to move on to the new screen? See, a few more pencils are moving. Flip your page over to the next page when you're ready. Okay. Cheesecake, milk, and raffle tickets. Each one of these is its own problem, 1, 2, and 3. And question 4 kind of ties them all in together. And it says, for each situation, find the unit rates. So what the heck is a unit rate? I mentioned it before, but what is this? A unit rate is when it is per 1. Remember how we talked about that here? Per means per 1. Per is per 1. And so that's what a unit rate means. It just means we want to write this so it's per 1. And I'll get you started on the cheesecake one, and then you guys need to work on 2 about milk and 3 about raffle tickets on your own. So how many ounces of cream cheese are there for every ounce of sugar. Oops, I should read the problem first. A cheesecake recipe says mix 12 ounces of cream cheese with 15 ounces of sugar. I'm going to color code again. So I'm going to go ahead and do the cream cheese in blue, and I'll do the sugar in orange again. And when I read this problem, and I think about what we did here, where we ended up with two ratios that were just flip-flopped, right? I had the orange over the blue, and then I flipped it to be the blue over the orange. We're essentially going to be doing that here. So which one do I start with? And the clue is right here. It says, for every ounce of sugar. And that means we want the sugar to become a 1. So again, remembering that unit rates mean we want it to be per 1. Looking at this problem, I know that I want the sugar to be the 1. A really good habit to get into is to then ask yourself the questions, how do I get this set up? And we get this set up by working backwards. We start at the end. We know that the end result is for us to have a per 1, so I'm going to have a 1 on the bottom here. And what is it that I want 1 of? It says 1 sugar. So I know that I want there to be 1 ounce of sugar on the bottom. And knowing that sugar needs to be on the bottom, that tells me that cream cheese needs to be on the top. Notice that I'm using some even shorter abbreviations this time. S for ounces of sugar and C for ounces of cream cheese. Just trying to save some time and not write quite as much, but I'm still using units so I can keep track of things. So again, I have a 1 on the bottom because it's per 1. Sugar is the unit that is on the bottom and is a 1. So now we're going to work backwards to the beginning of the problem and set that up. Knowing that sugar is the one that's supposed to be on the bottom, I'm going to put that original amount of sugar, which is 15 sugar, there on the bottom. And knowing that it's cream cheese that needs to be on the top, I'm going to go ahead and put that 12 ounces of cream cheese on the top. So again, I've set up the original ratio, but I set up the original ratio after I realized what the goal was. And the goal for this problem is to set it up 1 ounce of sugar on the bottom, and then I work backwards to the beginning of the problem and make sure that that sugar is on the bottom. And now we know the process for this. We now know that that 15 has to change to a 1. How does the 15 change to a 1? We divide by 15. And now that I know that this we're going to divide by 15, that means this is also going to be divided by 15. And 12 divided by 15 is equal to, I'll give you a second so that you can plug this into your calculator, because I want you online learners to plug it into your calculator the same as the in-person learners. And 12 divided by 15, there are two different ways that we can answer this. One way is the fraction 4/5. I prefer fractions, and you'll see why in just a second. So 4/5 is 12 divided by 5. If you want to write 4/5 as a decimal, you can, and that will be 0 8/10 ounces of cream cheese for every 1 ounce of sugar. And again, let's tie this back into our math practices. This is a very mathy, sort of abstract way of looking at this problem, and it's a very abstract answer. We have answered the question, but it is very abstract, and I want to make this quantitative. So I would rewrite this as a sentence and make sure that I understand that 0.8C or 4/5 C means 4/5 of an ounce of cream cheese for every 1 ounce of sugar. All right, let's follow that same strategy. Now, I've already warned you that these are basically going to be flip-flops of each other. And knowing that these are going to be flip-flops of each other, it does help us kind of get a head start on what we should be looking for on the next problem. But I still want to utilize that strategy of working backwards. This time, we are asked how many ounces of sugar is that for every ounce of cream cheese. Again, remember, this means every ounce of cream cheese means for every 1 ounce of cream cheese. It doesn't say the number 1 there, but that's what that means. And remember, we like that 1 to be on the bottom because that's what that per 1 or that unit rate means. So this time I'm going to set the 1 up on the bottom, but I'm going to be using cream cheese because it says every 1 ounce of cream cheese, so 1 C or 1 cream cheese on the bottom. And knowing that cream cheese is on the bottom, that tells me, of course, that sugar is going to be on the top. So I've set up the end of the ratio. Let's go backwards now and set up the beginning of that ratio. What does that look like? Again, I've got cream cheese on the bottom, so that means my original amount of cream cheese, which I'm finding all the way up here, is 12, and that is also going to be on the bottom. And the original amount of sugar is 15. Sugar is going to end up on the top, so of course that means it had to start out on the top. And now we have that same question that we've asked before. How does a 12 become a 1? And you know the answer to that. 12 becomes a 1 by dividing by 12. So I need to do the same thing up here. And 15 divided by 12. Again, I want to answer this 2 ways. Answer it with the fraction, and then also answer it with the decimal. 15 divided by 12. Enter that into your calculator. And 15 divided by 12, you should have gotten 5/4. As a decimal, that's going to be 1 25/100 or 1.25. Again, this is very mathy. So let's write it out quantitatively. 5/4 of an ounce of sugar for every 1 ounce of cream cheese. And the reason why I really like answering this question with fractions is because we can see a relationship. We have 4/5, and then when I flip it or reverse it, we see 5/4. Again, tie in that relationship. We know that word. This right here, those are reciprocals. We have seen that before, and I think that that's a really interesting thing to notice as we're working through these problems. What I want you to do now is I want you to pause the video and work on problem 2. Online learners who are watching this video, this lesson ended up taking a 3rd day, and so we started problem 2 in class, but we didn't officially finish it. So I want you to get started on it, pause the video and see if you can complete this problem, and then we'll return to the video as we work through it just to make sure that you solved it correctly. So pause the video now as you work on 2A and 2B. And we're back. Let's go over 2A and 2B. We have 10 gallons of milk every 6 weeks. Mai's family drinks a total of 10 gallons of milk every 6 weeks. So I've got my color set up, and now I'm going to read through part A. How many gallons of milk does the family drink per week? Again, we've got this terminology here. This per week means every 1 week. And that means we do need to set up a ratio where we have that 1 in the denominator, and that 1 in the denominator is talking about weeks. So I'm setting that up. Again, I'm going to abbreviate and just do 1W for weeks. And since weeks is going to be in the bottom, that means that obviously gallons, or G, would have to be on the top. Working backwards now, what does that mean for the original ratio? That means gallons is still going to be on the top, and that's going to be 10 gallons. And weeks is going to be on the bottom, that's 6 weeks. So we've set up the ratio, and again, we ask ourselves this question. We're so used to asking, how does this number change to a 1? And the answer is always divide it by itself. How does a 6 change to a 1? We divide 6 by 6. And now we know how it changes to a 1, so now we can focus on doing the same thing up here to the 10. And 10 divided by 6, I'm going to answer this 2 ways again. 10 divided by 6 is the fraction 5/3, 5/3 of a gallon. And that 5/3 of a gallon, if we want to, We can also write it as a decimal, and that is going to be 1 and 6 repeating. 5 divided by 3 is 1 and 6 repeating gallons per 1 week. Again, this is a very abstract answer, so to really answer the question fully, we would say something like 1 and 6 repeating gallons of milk per week, which of course means per 1 week. And so of course we know that the next step is going to be to flip-flop it. But again, let's really practice that strategy so that when we're not just doing the same problem in reverse, we know how to set up the problem. And it all starts with reading what's being asked. How many weeks does it take the family to consume 1 gallon of milk? That tells me that 1 and gallons is going to go on the bottom. And if 1 in gallons is going to go on the bottom, then of course weeks is going to go on top. So when I work backwards to set up that original ratio, I know that gallons is going to be on the bottom and the weeks is going to be on the top. How many gallons in the original? 10 gallons in the original. How many weeks in the original? 6 weeks in the original. And we ask ourselves the question, how does a 10 change to a 1? Of course, we know the answer is we divide it by itself. 10 divided by 10 is 1. So the 6 is also going to be divided by 10. Plug that into your calculator. And 6 divided by 10 is, of course, 3/5. I hope you're not surprised by that. 5/3, the reciprocal is 3/5. So just like we're flip-flopping and reversing the order of these ratios, we're also flip-flopping and reversing these fractions. We are getting reciprocals. Let's also turn this into a decimal, and the 3/5 of a week is 0 and 6/10 of a week per 1 gallon. So again, let's make this quantitative, this abstract answer. We would instead say 0 and 6/10 of a week, which is a weird way to say a little bit more than half of a week. It doesn't tell us exactly how many days, just 6/10 of a week to go through 1 gallon of milk. All right, I wish we had made it a little bit further, but that's as far as we made it in class today. So we will continue this lesson tomorrow and in the next video. That's all for now. Thank you. We'll see you next time.